see, here we have a circuit with 90 voltage source provided, and also we have a current source here. To apply with the mesh analysis, what we do is we assume the direction. I always assume clockwise. Let's call this one I1 and let's call this current I2. And what we do is we take each loop and apply KVL for it. So if I apply KVL at loop 1, KVL at loop 1, or you can say I1. So here if I'm looking at this loop, you can see this current is going from negative to positive. So this is going to be positive. That's a voltage rise, so positive 90 voltage. Sometimes you will see, when the current goes through negative to positive, they put a negative voltage, and when the current goes from this resistor, it's going to be plus minus, and for plus minus, some books put positive voltage. They put negative to minus as negative, positive to minus as positive. So it works out at the end because it cancels out and it works out at the end. So you can do both way as well. Like some of the universities also prefer like they put actually negative to positive as positive, and then positive to negative as negative to positive as negative, and then positive to negative as positive. Okay, so what you have to do is like you can follow any method, but it's better to like if you are following the other method or this method, if you keep one thing, like let's say if you take minus to plus positive, then you have to always take plus to minus as negative. Let's say you are taking minus to plus as negative, then you have to always take plus to minus as positive, right? So you have to keep up with the signs. If you keep up with the signs, you are going to get right answer in both way, right? So that's the only thing you have to be careful about. So this is like when the current goes from minus to plus, that's the voltage rise. So logically this is a positive. And then when the current goes through a resistor, there's going to be a voltage drop. So we can put a negative here. So this is negative, and then here instead of like for this one, we can use the Ohm's law, that is V is equal to I times R. And we know the current, that is I1 times R1, that is 9. Let's put 9 here. Or 9, you can write 9 I1. Okay, and here also is going from plus to minus, then it's going to be plus, actually sorry, minus I1, so 6 I1 because Ohm's law, 6 I1, and if you see the other current I2 is going opposite of this, so this is going to be minus I2 right here, and that's it. That's equivalent to 0. Let's go ahead and simplify this one. This is 90 minus 9 I1, and then minus 6 times I1, that's minus 6 I1, and then we have minus 6 minus I2, that is plus 6 I2. That's equivalent to 0. Now let's add the like terms. Minus 6 minus 6 minus 9 minus 6, that's minus 15. So 90 minus 15 I1 plus 6 I2, that's equivalent to 0. So if this is equal to 0, then I can equate this in terms of, I can bring the currents to one side and the numbers to the other side. So this is going to become, if I bring this currents to the other side, this is going to become 15 I1 minus 6 I2, that's equal to 90. Okay, and you can see this is all of them are multiplication of 3. So if I divide everything by 3, this is going to become 5 I1 minus 2 I2, and this is going to be 30 right here. Okay, so now we have simplified this equation, and we got this one, 5 I1 minus 2 I2 plus 30. Okay, this is now equation number 1. Now let's look at the other loop. In the other loop, we have a 5 ampere current. We have a current that's directly provided, and we assume the current direction to be this, right? So if I2 is this side and the same current is 5 ampere going this side, I mean in our case our I2 is equal to negative 5 ampere because we assume the opposite direction, negative 5 ampere. So since I have the negative I2 current, I can directly plug it right here and solve for it. I don't even have to do KVL right here. So I can directly plug it. So this is 5i1 minus 2 times negative 5. That's equal to 30. Therefore, this is 5i1 negative 2 times negative 5. That's positive 10. That's equal to 30. Therefore, 5i1 is going to be equal to 30 minus 10. Therefore, I1 is going to be equal to 20 divided by 5. That is 4 ampere. I1 is equal to 4 ampere. Now we have I1 is equal to 4 ampere. And the voltage here, if you have a plus here, the voltage here is also 90 voltage. Let's say this one is, we found the currents. We can calculate the voltages. So let's call this one V1. Let's call the voltage here is V2. So if you want to find V1, you can either use 90 minus V1 over 9 ohm resistor, or you can use this one, V1 minus 0 over V1 minus 0 over 6. Okay, so this one may be easier because if you do this, okay, maybe this is easier as well. Let's try. Let me get rid of this. If I'm doing here, I'm going to deal with 2 current. If I'm doing here, I'm going to deal with another voltage. So let's go for this one and ground. You know, the bottom part is always a reference voltage. So this is 0 voltage right here. And if we assume this direction, current is in this direction. So this is going to be V1 minus 0 divided by the resistance in between. That is 6. Okay, what I'm calculating. So according to Ohm's law, I is equal to V divided by R. This is our V divided by R. So that's going to be the current. Current is I1. If I assume the bottom direction, I1 minus I2. So this is V1 over 6 is equal to I1 minus I2. So I1 minus I2. I1 is what? I1 is 4. Minus 5, that's 9. 4 plus 5, that's 9. So V1 is equal to 9 times 6. 9 times 6 is 54. So V1 is 54 ampere. 54 voltage actually. So this one is 54 voltage right here. If this is 54 voltage, then what is this voltage is going to be? We can apply a current equation and find it. Let's get rid of this one. I note this I is equal to, this is I1. Okay, let me note this one somewhere. I1 is equal to 4 ampere. I'm going to erase this one. Okay, let's solve for this voltage. This voltage, if I assume current 5 ampere in this direction, current flows from higher potential to the lower potential. So it's going to be V2 minus V1 divided by 8 is going to be equal to 5 ampere. So V2 minus V1, we already know this 54, and then 8 times 5, that is 40. 40 plus 54, that is 94. It is equal to 94 voltage. So now we have solved for the all the currents and all the voltages. And that's how we can use mesh analysis solve problem like this. I hope you guys find this video helpful. Thanks for watching. Don't forget to subscribe my channel. See you guys on my next video.